Lesson 8.2, volume of cones. It's our same standard. I can develop and apply formulas for volume of cones. Now remember, a cone has one base, goes to a point. Volume is 1/3 capital BH. 1/3 capital BH. So we have this lovely cone. It has a height of 3 and a diameter of 6. Volume is 1/3 capital BH. Area of the base, pi r squared. Pi times, now if the diameter is 6, that means the radius is 3. So we get 9 pi. So my volume is 1/3 times 9 pi times a height of 3. 1/3 and 9 times 3 is 9 pi. I multiply that out. 9 pi is 28.27 to the nearest tenth, 28 3/10 feet cubed, because it's volume. So our standard, again, we're working with volume of a cone and using that formula to develop and find that volume. Now, this is a lovely pyramid. It's not a cone because the shape is a pentagon. So volume is still 1/3 capital BH. Volume of a pyramid is 1/3 capital BH. So, oh, look at this. They gave me capital B. I don't know how to find the area of a pentagon, so they gave it to me. I'm so excited. So 1/3 times 24 times a height of 8. 3 goes into 24 8 times. 8 times 8, 64 feet cubed. Pretty cool, huh? Yay. That was nice. I like that one. Find the volume of a rectangular pyramid. Okay, so I have a rectangular base. It's 2 meters by 6 meters, and it has a height, straight down here to the middle, of 3. So the first thing we kind of have to do is draw our shape. Draw our three-dimensional figure. Volume is 1/3 capital BH. Area of the base, it's a rectangle. Length times width, 12. So volume is 1/3 times 12 times a height of 3. Volume is 3 goes into 12, 4 times 3, 12, labeled meters cubed. I kind of like that one too. Find the height of a cone if the volume is 75 cubic yards. Round it to the nearest yard. So, volume equals 1/3 capital BH. Now, the area of the base, we know that that is 6 yards for that radius. So, pi r squared, so pi times 6 squared, 36 pi. My volume is 75, 1/3 times 36 pi times h. We don't know what h is. So 75 equals 12 pi times h. Because 3 goes into 36 12 times. Divide by 12 pi. Now remember, when we did this before, remember, when we divide that, we got to be super sneaky, and we have to have 75 divided by parenthesis 12 pi. And we get 1.989. And rounded to the nearest yard would be 2 yards equals h. Here we have a lovely little hourglass, and the sand is running out at 150 cubic millimeters per second. How much time do you have to answer the question? So we have a radius of 15 and a height of 36. So volume is 1/3 capital B H. Area of the base, pi r squared. Pi times 15 squared, 225 pi. So the volume of that top section of our timer is 1/3 times 225 pi times a height of 36. Oh my goodness. So 1/3 times 225 times 36 is 2,700 pi, and we multiply that, and we get 8,482 millimeters cubed. Now, that doesn't answer the question. The question says it falls at 150 millimeters cubed per second. So now we have to take that and divide by 150. And we get 56.5, or about 57 seconds, rounded. So if they told you that's a minute timer, they lied. It's only 57 seconds. Again, our standard, which says I can apply and use the formulas for volume of cones, and we just did cones and pyramids. I can find the volume of cones, I can find the height of cones given the volumes, and I can solve real life problems.